about an inverse, and he said we're going to switch the x and y. And then we're going to solve for y. So that's what we did a bunch.
Mr. Rice,
Yep.
you want us to write this down on the blank sheet?
Yeah, you can have that as you're going. This is just kind of giving that to you there to write some things down. We'll do some problems there a little bit later, so you'll need some of that there too, but just kind of getting some of this here. All right. Switch x and y, we said they're kind of like opposites. All right. It's an undoing process. So if we said addition, how do you get rid of addition? You subtract. If we say multiplication, how do you get rid of multiplication? We divide, all right? So we've done squares, square roots, we've done exponents, we've done logs, we've done a lot of those things, so we saw a lot of that there. In order for something to be an inverse, it has to be a one-to-one function. Anybody remember what a one-to-one function is? One input, one output, good. And kind of the other way too, one output, one input. So every x has exactly one y, every y has exactly one x. So that's one-to-one. Graphically, when we're talking about the line test, it passes the vertical line test, and it passes the horizontal line test. Passes both. So it's got to pass the vertical line test and the horizontal line test. Okay?
What's that again?
If it's a one-to-one function. Okay? So if it's a vertical line test, if I draw a vertical line, it can only hit my graph at one point at a time. All right? So if you were thinking about a parabola, all right? So if I were to sketch a parabola real quick, if I had that there, a parabola would pass the vertical line test. If I did that, that vertical line's only hitting that parabola at one point at a time. However, it would not pass the horizontal line test because it's hitting twice. So a parabola is not a one-to-one. So if you remember, we had to make it one-to-one. We had to kind of cut it off and split it like that and only do part of it. Okay? And so we've got to be able to do that. Now, just real quickly, the graphs that we've been doing, if I were to give you an example of one, we've been doing something like f of x equals sine of x. So that's what we're going to talk about today. We're going to talk about the inverse graphs of these trig functions. All right. So if we were simply going to solve for the inverse, we would take the x and the y and we would switch them. So we'd do that. You could use f of x if you'd like. Okay. And then we say we want to solve for y. Well, how do I get rid of this sign right here? Do you divide by it? It's not really multiplication, right? It's a negative sign, all right? And so we're going to use the inverse sign is what we're going to do. So we would take and we would do the inverse of this side right there, and they would cancel each other out. But then we would do the inverse on that side right there as well. So our inverse would be, this is referred to as arc sine, A-R-C sign, or the inverse sign. So it's kind of got two names that we use, arc sine or inverse sign there. And we're going to build that graph today. We're going to actually build three graphs today. We're going to build arc sine, arc cosine, and arc tangent. Okay? All right. So first things first, let's go to, I'm going to add a graph on here. Bless you. All right. And so you have some graph paper. All right. Take a copy of it so I can put it into my notes so you can follow along. All right. So here we go. So the first thing that I want to do here is I want to graph. I want to go back to what we did last week, and let's go graph or what we've been doing, let's go graph sine of x. Just the parent function for sine of x. So you could use like the top graph on here to do that. So let's revisit what we know about sine. Where does sine start? At the middle, on the midline. Okay? So sine starts here. All right? What is the period of a sine graph? How long does it take for the sine graph to go all the way around and back up?
6.28.
6.28, we're talking radians there, or 360 degrees. All right, I'm going to do this in degrees. So I'm going to go 30, 60, I'm going to call that 90, 120, 150, 180, 210, 240, 270, then 300, 330, and this would be 360. If you want to count on your graph, that should be 12 spaces. Now, I should see an entire sine graph in this spot. Now, if you remember, sine graphs go up, they go back down, and they come back up to the midline. So halfway between these two, in the middle would be at 180, it's going to hit the midline again. So it's going to go above, it's going to hit the midline, then it's going to go below, and then we'll have a full graph. At 90 in the middle is where it hits its high point. It hits a high point at 1. So that graph goes there. At 270, it hits its low point down here at -1, and it goes there. Okay? So that's a sine graph. That's how I would draw it. That's what I would do there as you want. Now, question. Is a sine graph a one-to-one function? No. Is it a function? Does it pass the vertical line test? Yes, but it does not pass the horizontal line test. So I'm going to have to restrict this a little bit as I'm going. Okay? Do you want this part of the graph right here? Does this pass the horizontal line test when I start off? I'm good to about right here, correct? That part passes the horizontal line test, but once I get over that top, then I'm going to start repeating and it won't pass it. Now, I can draw the rest of this graph as well. So if I go backwards here, if I were to count back 3 this way, 1, 2, 3, then I'd be at this low point here. If I count 3 more, 1, 2, 3, then I'm back at the midline. 1, 2, 3 more, I'm back at the high point. 1, 2, 3 more. So now I have 2 periods of the graph here. And that's kind of helpful. Okay? So a sine graph, I'm gonna restrict its domain. I'm gonna restrict it from -90 to +90. Or if we're doing that in radians, it would be -pi/2 to pi/2. I'm going to restrict it there. So I'm only going to graph this part of it. If I only graph that part right there, let me do it in a little bit different color so you can see it. If I only do that part right there, is it a one-to-one function? Yes. So I have to make it one-to-one before I can find the inverse. Okay with that so far? Yep. Bless you. And so what I'm going to do is I'm going to use the graph below that, and we're going to draw the inverse graph there. Okay? So let's talk about it. So as I go to draw the inverse graph, what's going to happen with my x's and my y's? They switch. That's correct. Okay? Sorry. Building this a little bit. All right. So they're going to switch. So now if they switch, what's going on my x-axis or on my y-axis now? The angles are going to go there, correct? And then on this one, this is just going to be my numbers or my y values or whatever. Okay, so my y values are getting switched there. So what point, if we were to look at this graph right here, what would be a good point that we could take and put on our inverse graph?
0, 0.
0, 0. Okay, 0, 0 would be a pretty easy one. So I'm gonna take and I'm gonna put 0, 0 on my inverse graph. What would be another couple points that would be really good? 90 degrees and positive 1, and negative 90 degrees and negative 1. So if I take both of those and I switch them, and so we had 0, 0, and then we have 90 is going to go there and 1's going to go there, and negative 90 is going to go here and negative 1's going to go there. I think we have quite a bit of information there as we're going. So if that was the case, all right, I'm going to go 1 and I'm going to go 90, which would be technically 3 spaces because that'd be 30, 60, 90. All right, I'm going to go negative 1 and negative 90. And so there would be my graph right there. Now you notice I didn't put any arrows on this graph, correct? Because this graph is stopped. It's just right there. Okay? Now let's go verify this with our calculator. All right, so grab your calculator. And so I'm going to go on. I'm going to go new. No, I'm not going to save that. I'm going to go add a graph. You can graph this in radians or degrees. I'm going to graph in radians just because it's going to be a little bit smaller window. It's going to be a little bit easier to see. And the first thing I'm going to graph is I'm going to go graph the sine. Try that again. Go graph the sine of x. So that's our parent functions. That's where we started. So if I'm in radians, I should get a pretty nice, easy graph there. So that's what we started with. Now, I'm going to hit tab. And the way that I'm going to graph the arc sine or the inverse sine graph is I'm going to go back to trig. And if you notice, all these bottom ones are all the inverses of what we have. So I'm just going to select the inverse sine. I'm going to put an X in there. And I'm going to graph that right there. Okay? And you notice it drew pretty much what we just had. Okay? So we have that there. Now, there's one other thing I want you to notice about these two graphs here.
Please pardon the interruption. If you have not submitted your attendance, please stop what you are doing and do so now. If you have not submitted your attendance, please stop what you are doing and do so now. Thank you.
That's when it's official. Third period is the official time. All right. So if we do this right here, only look at this part of the graph right here. Like we cut everything else off. We're just kind of looking at that little middle part of the graph. If you notice, this is nice and symmetric. When we're talking about inverses, they are symmetric. We didn't add this a while ago, but they're symmetric over the line y equals x. So if I were to draw that in there, technically I could just go, all right, graph x, all right, graph y equals x. If I did that, then if you notice, that's like splitting that in half. That's a nice even symmetry line there. And so that's also one of the characteristics that we have. Okay?
Mr. Rice?
Yes.
Why does the inverse line not, it's just a little portion, it doesn't continue?
Because it has to be, in order for us to have an inverse, it has to have a 1-to-1. All right? So yes, the sine graph, its original goes on and on, but what we're saying is we're only restricting it from here to here. All right? So technically we're saying the sine graph only exists there.
Why?
Because it's got to be 1-to-1. It's got to, anything that have an inverse, it's got to have 1-to-1.
But why does it have to be 1-to-1?
Because it would have too many different answers, all right, on it as we're going. Because if I did this, then it would break and then have another one. It would kind of look a little bit like the tangent graph. But when I'm using it to solve, all right, I need to be a certain specific spot in the graph to work, all right? And so anytime that we're using that, I mean, we did the same thing with, if you remember with the parabola, we had parabola here, and we didn't use that part, we just used this part. And when we did that, it created a square root graph. Alright? And so on a square root graph, we just say square root. If we wanted to graph more of it down there, we could say plus or minus, but that's not normally what we do. We just normally list that. And so when we're looking at, for an inverse, everything has to have equal back and forth. Here's the other reason too. The function and its inverse both have to be functions. And so if it passes the horizontal line test, then when I go to this, now this inverse would pass the vertical line test and it would be good. It would be a function. So we don't want the inverse not to be a function.
Okay.
That's the reason. All right. Yeah, I know it's kind of
Doesn't
silly,
really make any sense.
but it doesn't. All right. Later on, it might make a little bit more. I know we won't talk about more. We're going to use it for solving on Friday, and it help make a little bit more sense then. But until then, that's kind of what it is. Yeah. All right. So let's do this. Let's turn your graph over, and what I'd like for you to do is I want you to sketch me a cosine graph. So once you take another graph, you ought to have like 4 pages of graphs, so we got plenty of room. And I want you to go graph me a cosine graph. See if you can do another graph and graph it. All right. So how is a cosine graph different than a sine graph? It starts at the highest value, so it starts up here. And so where would I see another high point? Well, I'm going to count 12 like I did a while ago. So I'm going to count it the same way, 30, 60, 90, so forth. So I'm going to count 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So that's one period. So high to high. Where would the low be?
180.
180 would be in the middle, and it would be at -1. That's good. 1, 2, 3, 4, 5, 6, and down here. So that's where the low is. In between the lows and the highs, I hit the midline. So halfway, I hit the midline. So this is a cosine graph. If you'd like to continue to draw this way, we could. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It would repeat again in that section. 1, 2, 3, 4, 5, 6. Down here. Okay. Now, again, does the cosine graph pass the vertical and the horizontal line test? Passes the vertical, but it doesn't pass the horizontal. So I'm going to have to kind of restrict it as well. Now, I drew the whole thing. I drew 2 of these, but I didn't really need to draw 2 of these this time, because what do you notice? Where am I gonna? We're gonna truncate or crop or whatever this function. From here to here. All right. Because I don't want this side over here because it matches here, correct? It wouldn't pass a horizontal line test. So the nice thing is if I change it from here to here, then I get kind of what I want. Am I all right with that? So these points, if I were to pull these points off, if I said x and theta, then I want 0 and 1. I want 90 and 0. And I want 180 and -1. So that's the points on here, but what am I going to do with those points? I'm going to flip them, okay? I'm going to take those points and I'm going to go to my second graph on the page, all right? So let's go graph the inverse cosine. So if I graph the inverse cosine, here we go. So if I flip it, the first one we have, by the way, my angles are gonna go here, and my X's are gonna go here. So we had 0 and 1, so now we're gonna have 1 and 0, so it's gonna be there. All right, the next one we had 90 and 0, so it's going to be 0 and 90. 0 and 90, so it'd be like 30, 60, 90. I know I'm not going to be on the page, it'll be all right. And then the last one, we had 180 and -1, so we'll flip it, we'll have -1 and 180. So -1 and then 180 would be up there. Let me move my equation just so I can graph that a little bit better. All right, and 1, 2, 3. So it would be right here.
It's a very sharp line.
Say again?
It's a very sharp line.
Yeah, it is. Well, and it depends on how you have it scaled too. All right, and so real quick, as we look at this. I want to compare the two values here. So if I go about the sine, what is the domain and range for this sine right here? For the inverse sine, I should say, sorry. What's the domain for that graph right there? -1 to 1. You do it like that, or you could do it like this. I don't care how you write that, whatever notation you like there. Okay? What is the range for that? Say again? Not quite, because it doesn't keep going, right? 0 to 180. I think you're on the cosine one. I went back to the sine, sorry. So the sine graph, this is the inverse sine. -90 to 90, okay? So -90 to 90 degrees. If we were talking about radians, we'd go -pi to pi. So there's that right there. So that's the inverse sine. So there's my domain and my range for the inverse sine. And then let's do the same thing for the inverse cosine.
Wait, wouldn't the range be pi divided by 2 or -pi divided by 2?
Ah, thank you. Yes. Good pickup. Pi over 2 and negative pi over 2. Thank you. It's Monday morning math for you. Thank you. Excellent. All right. All right. So if we were to go to sine, not sine, but if we were to go to cosine, and if I was going to do the inverse cosine, and if I was going to do the same thing here, and I wanted to find the domain and the range for the inverse cosine, all right, what's the domain for the inverse cosine? -1 to 1. So what do you notice about the two domains? They're the same, right? Because the two ranges of the normal one were the same. How high and how low did the sine and the cosine graph go?
1.
Went up to 1, down to -1, right? That was my y value, that was my range, but now what is it? Now that it's my domain, because I've switched the x and the y's. Got it? What's my range for this one? 90 to 180?
Or 0 to 180.
0 to 180. 0 to 180. So 0 to 180 degrees, or we could say 0 to, that one's pi there. Okay? So the range looks a little bit different now. Okay? Quick question. Which quadrant is this in? This range? Huh? First one? And second one, right? So this is graphed through the first quadrant and the second quadrant. That's 0 to 180. Where's this one? Not quite. How do I move negative 90? Start here and move downward. So this one's the first and the fourth is what it's using. Okay? So that's one of the big reasons they're different. It's just looking at different spots to find the answers. All right? I'm needing a sign to be positive and negative. You with me? I'm needing the inverse sign to be positive and negative. Well, where is sign positive and negative? Positive in the first quarter and negative in the fourth quarter. All right? First and second would still be positive. The sign, the Y, would be a positive up here. So I need it to be a positive Y and a negative Y. So that's why it's working like that. I don't really want to jump from first to third. I want it to be continuous. The cosine, the inverse cosine, it's positive in the first, and then as it moves around the circle, it's negative in the second because it's x. Cosine is x. So positive x, negative x, right there. And so that's kind of how that's working. All right. Let's do one more graph. So let's go look at a tangent graph. All right, what do you remember about a tangent graph? We just talked about that last week.
It repeats a bunch.
It repeats a bunch. Does it look like sine and cosine?
In a roundabout.
And a roundabout. It had some of the characteristics, but it looks a lot different. What's one thing that's different? It does start at 0, 0. A tangent graph starts at 0, 0, bless you. All right. What else is kind of different about the tangent graph? Say again? It is our slope, all right, of that terminal line. How often does it repeat? It does repeat. How often though? What's the period? 180 instead of 360. So it repeats faster. It also has a characteristic in the graph that the other ones didn't have. 1, 2, 3, 4, 5, 6, 180. That's 180 right there. But in the middle of those points, it has asymptotes. That's one of the biggest things that it's different about. So every 180 it repeats, and there's asymptotes every 180 as well. They're in between there. Okay. And so we had these graphs that looked like this. This was a tangent graph. Okay. Does it pass the, is it a one-to-one function? Does it pass the vertical line test, horizontal line test?
Vertical, yes.
Yeah. Horizontal, maybe not. But what do you see? They're already kind of segmented, right? And it's a little bit different. It's not a continuous graph like the others. And so, what if I went from this asymptote here to this asymptote there? Does this red line pass the horizontal line test and the vertical line test? That piece does already, right? So we're just going to take that piece right there in the middle. So we're going to only go from negative 90 to positive 90. We're only going to graph that part. So we have a couple things here. We got 0, 0. So I'm going to take and I'll switch that here in a second. Now, when we were graphing this the other day, if we were to go halfway between here and go up 1, there's a point there. Halfway between here and go down 1, there's a point there. So I didn't draw this graph really well. It should look more like that. Okay. What's halfway between 0 and 90? 45. So at 45, it goes up 1. Now, we mentioned that a while ago. You mentioned that it was slope, that tangent was slope. So on a 45-degree angle, the slope of a 45-degree angle is 1. So that's kind of what we're relating here. So this is the angle, and then that is the slope. So on negative 45 degrees, that is a -1 as a slope. So those are the 3 good points that I'm going to use to help draw this graph. So I'm going to draw an inverse tangent graph. So if I were to go draw inverse tangent, give me some graph paper. All right, so inverse tangent. What kind of asymptotes did I have in the other one? I had vertical, and where were they? They were every 180, all right? But exact location of it
Oh, 90.
is at 90. So I had a vertical asymptote on that one. I'm going to have a horizontal asymptote in the inverse. So at 1, 2, 3, that would be 30, 60, 90. I have a horizontal asymptote. At negative 90, I have another horizontal asymptote. So my asymptotes get carried over as well. If I were to flip 0, 0, that's easy. That is 0, 0. Yep. If I flip 45, 1, it's now going to be 1, 45. If I flip negative 45 and negative 1, it's going to be negative 1 and negative 45. Yep. Now, the asymptotes help me here because all of our other graphs have done like this and kind of stopped like that. This one actually kind of goes more, but it's going to flatten out because it's going to hit that asymptote here. Didn't do a very good job of drawing that, sorry. So the tangent and the sine and the cosine have a lot of commonalities. The tangent's the one, it shares some properties, but that's a lot different as well. Now, again, I can go to my calculator and I can go graph that. So if I were to go there, I'm going to start new. I'm going to go on new. I don't want to save that. I'm going to add a graph. And I'm going to do the inverse tangent graph. The one that we just graphed there. So if we're to do the inverse tangent, then that does look very similar to what we just graphed there. What would the domain of this graph be? All real numbers. Good, because the range of the tangent graph is all real numbers. All right. What would be the range of this graph here?
1 to -1? Or
Negative 90 to 90.
Negative 90 to 90, yeah. All right, so that's what we use. We would use 90. Now you could use pi over 2's as well. So if we were to write the domain and the range here, the domain would be all real numbers, and the range. Now here's what's a little bit different on this one. I'm going to use parentheses instead of brackets. Or you could write it like this as well. Why does it get written differently? Because it has asymptotes. It's not going to ever touch there. Good. All right. So it hits the asymptotes. It's not going to ever touch there. It's going to be, it's going to level off, and it's now never going to quite get there. Okay. All right. We're going to take a little break right now. I'm going to come back and do a couple of other things here in a second. All right. Give you a little bit of downtime because we've been going for a little bit of time.